Welcome Pre-Cal students to the homework help video, page 633, numbers 45 through 69, every other odd. Let's go ahead and get started. Please get out your homework, your books, pens, pencils, calculators, and let's get started. Either you're going to do these problems with me or you've already worked them out and you're checking your work. So here we go. For number 45, the directions say raise the number to the given power and write your answer in trig form or trig notation. So this will be pretty easy. We're simply going to take this 2 right here and we're going to raise it to the third power because we have a 3 right here. So to the third power. And then I really do like to work with degrees. That's just me. So pi over 3 is 60 degrees and pi over 3 is 60 degrees. Now we're going to multiply 60 times 3. So we would have cosine of 180 degrees plus I sine of 180 degrees, which is what I taught you to do when you're taking a complex number in trig form. You take this number here, raise the outside number to that power, and you take your angles and you multiply them by that number right there. Now, the only thing I would like you to get used to doing is whenever your original problem is given to you in radians, you really should write your final answer in radians. That's just the right way to do it, and get used to that for college. So I'm going to convert 180 degrees back over to radians. And we're finished. Where did the 8 come from? 2 times 2 times 2 is 8. And then cosine of pi plus I sine of pi. And we're done with 45. Let's take a look at number 49. Now the directions for 49 and 53 read as follows. Raise the number to the given power and write your answer in standard form or standard notation. So here we go. First of all, we're going to take this 3 right here and raise it to the third power. So 3 to the third power. Then we're going to take 20 degrees and we're going to multiply it by 3. Alright, now I actually should have had this done already, and I apologize that I don't. It's totally my fault, but very quickly here. Let's get our table. We're going to pull this table up once and for all, and we will have it to constantly use. And I'm just going to have it right here. We'll just flip back and forth over from page to page. So now we have 3 times 3 times 3, so really we have a 27 right here. And the directions say to write your final answer in standard form. So let's take a look at the cosine of 60 and the sine of 60. The cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. So the cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. Of course, we put an I with it, put a plus sign between it, and on the outside we still have 27. Okay? 27 times 1/2 would be 27 over 2, plus 27 times square root of 3 over 2 would be 27 square root of 3 all over 2 I. Okay? And that would be your answer to number 49. They want your final answer in standard form. Alright, let's go ahead and continue on. Let's take a look at number 53. Okay, now they want us to raise this to the 12th power. Can you imagine how long that would take if we were doing that in standard form? I mean, that would really be crazy. So we're going to first of all convert this over to trig form, okay? And it shouldn't take too long to do. I mean, I quickly draw my triangle like this, and I know I'm going to go over a positive amount and then down a negative amount, so I really don't care if my dot's in the right place. I just want to get a big triangle that I can work with here, okay? So I'm going to go over 1 over square root of 2, and don't forget that's just square root of 2 over 2. I'm going to go down 1 over square root of 2, which is the same thing as square root of 2 over 2. Now let's find the hypotenuse. So let's see, if I squared this, I would get 2 over 4, which is 1/2. And if I were to square this, I would get 1/2. Add them together, you get 1. The square root of 1 is 1. So I do what I do there very quickly. We should know how to find the hypotenuse. My only concern on this problem here, I think you're going to need a little more help. So let me show you what I did here. I squared the square root of 2 over 2 plus I squared the square root of 2 over 2, and it's all under a square root. Now, when you square the square root of 2, you get a 2, and when you square your denominator, you get a 4. Same thing here. When you square the square root of 2, you get a 2, and when you square your denominator, you get a 4. If you add those together, you get 1, and the square root of 1 is 1. So that's how I know the hypotenuse is just 1, okay? So I put a 1 here, and now let's find this angle. And I say tangent of x equals opposite over adjacent. Well, guys, the square root of 2 over 2 all over square root of 2 over 2. And anything over itself is just 1. So what angle, when I take the tangent of it, gives me 1? Well, let's see. Tangent of 45 is 1. Tangent of 45 is 1. So I know this angle right here is 45 degrees. So I rotate around 315. So I have a hypotenuse of 1 and an angle of 315 degrees. So just like that, I have quickly written this in trig form, excuse me. So my hypotenuse is 1. And I would have the cosine of 315 degrees plus I sine of 315 degrees. So I'm going to quickly get rid of this. No longer is it needed. And this is the new problem I'm going to deal with. And I believe I was raising that, if I remember correctly, to the 12th power. So there should be a 12 right here. Okay, remember what to do. Whatever this outside number is, we raise that to that power. And then on the inside, we take 315 times 12. So 315 times 12, I would like to say I could do that in my head, but I can't. That's going to give me 3,780. So 3,780 plus I sine. There we go. Now, I believe we would go around 9 times. No, we go around 10 times. Guys, I'm sorry, my throat's really bothering me. Excuse me. Sorry about that. So I'm going to go around, I have 3,780. Well, first of all, sorry, 1 to the 12th power is 1, so that takes care of that. And then 3,780, I'm going to go around 10 times. And if I go around 10 times, that's 3,600. So I'm left with 180. So I'm going to end up going around 10 times, and then my last turn, I'll stop right there. So 180 degrees, okay? So I'm going to put cosine of 180 degrees plus I sine 180 degrees. Okay? And now let's just go ahead and figure this thing out. 180 is not on your table, so we have to use our calculators. If you take the cosine of 180, you will see you'll get 1. And if you take the, you get negative 1, I believe. Yes, negative 1. And if you take the sine of 180, you get 0, so plus 0i. Multiply your 1 through, and your final answer is this right here. You do not need to put the 0i if you don't want to. There we go. Really not that bad, okay? Let me get a drink of water here. And let's continue on. Now let's take a look at number 57. The directions for 57 say, take the square roots of this number. So we're going to find the square root of this number. Now, we first of all have to quickly write it in trig form. So I know I'm going to go over a positive amount and down a negative amount. So there's my triangle. I really don't care if it's drawn to scale. I know this length is 2 square root of 2 and this length is 2 square root of 2. So if I use Pythagorean's theorem and I say 2 square root of 2 squared, 2 square root of 2 squared, well, when I square the 2 I get a 4, and when I square the square root of 2 I get an 8, or 2, excuse me. So I square the 2, that's a 4, square the square root of 2, that's a 2. 4 times 2 is 8. I would get the same thing over here because it's the exact same number, 8. 8 plus 8 is 16, and the square root of 16 is 4. So my hypotenuse will be 4. Not too bad. Now, my angle, if you'll trust me, is just going to be 45 degrees like the last problem, okay? Because if you're trying to find the tangent of that angle, tangent of x equals opposite over adjacent. So it's going to be 2 square root of 2 over to square root of 2, which is just 1. And the tangent of 45 degrees, if you look at your table, the tangent of 45 degrees gives you 1. So I'm going to rotate around 315 degrees. So my hypotenuse is 4, and my angle is 315 degrees. So just that quickly, I can write this complex number in trig form. So my hypotenuse is 4, and my angle is 315 degrees. And we're going to take the square root of this. I'll put it off to the side. We're going to take the square root of this. So remember what I've taught you. Whatever root you're doing, you take the root of the number on the outside, so the square root of 4, and then on the inside you divide this number by 2. So we're going to get a decimal, which is okay. 315 divided by 2 would be what? 157.5. 157.5 minus I sine 157.5. Now, there's one more simplification I can do. The square root of 4 is 2. So I'm going to put a 2 here, and then cosine of 157.5 minus I sine 157.5. Now remember, we're finding the square root of this, and that means there'll be 2 answers. If it was the cubed root, there'd be 3 answers. So here's one answer here. Alright, now let's find the other answer. Now how I've taught you to do that is you always take 360 and you always divide it by whatever your root is. In this case it's a square root, and we're going to get 180. So that's what we add to our angles, is 180. So we're taking 157.5 plus 180. And so what we're going to get for our other answer is 2 parentheses cosine of 337.5 degrees plus I sine 337.5 degrees. Now, I'm the one that picked out this textbook and I really like it, but this is one area here I'm about ready to show you that I disagree with in the directions here. It doesn't, if you'll look in your book on your homework here above number 49, it says raise the number to the given power and write in standard notation, which is fine, but then when you look at the directions for 55, 57, all those, it doesn't say what form to write it in. Now when I was looking at 157.5, I was like, wow, great, it's not on our table. I have to use a calculator to get a bunch of decimals. So I looked in the back of the book and they want you to write your answer in trig form. So I'm okay with that. I would rather have it in standard form, but then again I really don't like angles like this either. So this is totally fine. And when you're not sure how to write, what form to write your answer in, look in the back of the book and see how they wrote their answer, and then just write your answer in that form. If it's a test or a quiz, just ask me and I will tell you if I haven't already stated in the directions what form to write your answer in. Okay, so there's the 2 square roots of this trig number here. Excuse me, of this complex number here. All right, 61 is next. We only have 3 left, so hang in there. 61, 65, and 69. All right, let's take a look at number 61. First of all, the directions for 61 says find the cubed roots of this number, cubed roots. So off to the side, I'm going to write cubed roots so we don't forget that. And now let's quickly write this in trig form. I know I'm going to go over positive and down negative, so I know my triangle will be down here. I went over to square root of 3. I went down 2. Now using Pythagorean's theorem, if I square 2 square root of 3, I square the 2, that's a 4. Square this, that'd be 3, so I would have 12. If I square the 2, that's a 4, so 12 plus 4 is 16. So the square root of 16 is 4. There's my hypotenuse. Now let's find this angle. The angle would be the tangent of some angle is opposite over adjacent. 2 over 2 square root of 3. Your 2's cancel, leaving you with a 1 up top. And we know that 1 over square root of 3 is square root of 3 over 3. So now I've got to find that missing angle right there. So the tangent of 30, the tangent of 30 would give me square root of 3 over 3, the tangent of 30. So I know that my angle inside the triangle is 30, so I'm going to rotate around to the hypotenuse. That's 330 degrees. So my hypotenuse is 4, and my angle is 330. My hypotenuse is 4, and my angle is 330 degrees. And I'm going to take the cubed root of this number. So here's what I've taught you to do. I've taught you first of all to take the cubed root of this number, so I have the cubed root of 4. And then I've taught you to take this number here and divide it by whatever the root is. So I'm taking 330, or the index, and I'm dividing it by 4. And what you would get is 82.5. So I have the cosine of 82.5 plus I sine 82.5. Now, I've not looked in the back of the book yet. I'm going to assume they want you to leave your answer in this form. And on a test or a quiz, I would really like you to just leave your cube root of 4, just a cube root of 4. I don't want a decimal there. Now, if it was a perfect cube, if it was the cube root of 8, then go ahead and put 2, because the cube root of 8 is 2. But in this case here, I'm just going to leave it 4. Now, we're finding the cubed root. That means we'll have 3 answers. That means we need 2 more answers. So remember, you always take 360 and divide it by whatever your root is, or your index, and we get 120. So we're going to take 82.5 and we're going to add 120 to that, and when we do, we'll get 202.5. So now I have cube root of 4 cosine 202 cosine of 202.5 plus I sine 202.5 degrees. Now we're going to add 120 degrees again. So here we go, cube root of 4, and then 120 would be 322.5 degrees plus I sine 322.5 degrees. Okay, so there's your 3 answers. I knew that I had 3 answers because I was asked to find the cubed root. I knew that I was adding 120 degrees because you always take 360 and divide it by whatever the index is. And of course, I knew that I had cube root of 4 because you always take whatever root you're finding, you take the root of that hypotenuse, or of the outside number, however you want to say that. Okay, and so I'm looking now quickly. I always try to check the answers to make sure we're correct, and I believe this was number 61. I'm looking in the back of the book, and it should be good. Okay, moving on to number 65. Number 65. Okay, number 65 says find and graph the fifth roots of -1. Now, I'm not really seeing it necessary to graph these. It's going to take a lot of time. We've graphed a lot of these already, so I'm not worried about that. But we're going to find the fifth root of -1. Now, we understand -1 is a complex number, so it's -1 plus 0i. So if I was to very quickly write that in trig form, this should be really easy to do. I mean, I go over -1, and I'm not going to go up, and I'm not going to go down, so my point stays right there. So if that's my point, then I draw, I guess you can call it your smashed hypotenuse. So there it is. I have a length of 1, and I rotate 180 degrees. So that's it. It's that easy. So a hypotenuse, or a length of 1, and we rotate 180 degrees. So there we go. So the trig form would be 1 cosine 180 degrees plus I sine 180 degrees. And don't forget, they were asking us to find the fifth root. So that means I'll have 5 answers. Now, first of all, I take the fifth root of 1. So there's the fifth root of 1, and then here I divide 180 by 5. So the cosine of 5, or the 180 divided by 5, would be 36 degrees plus I sine of 36 degrees. Now there we go. That's one answer. In fact, I'm going to separate it just a little bit from that top answer, okay? There we go. Now, remember, if we're defining the fifth root, we're going to have 5 answers, so we need 4 more answers. So you always take 360 and divide it by your index, or whatever your root is, which is a 5. So when you divide 360 by 5, you're going to get 72 degrees. So we're going to add 72 over and over and over. And by the way, let's just go ahead and get rid of the fifth root now. The fifth root of 1 is 1. 1 times 1 times 1 times 1 times 1 is 1. And so that means that the fifth root of 1 is just 1. So I'm going to very quickly get rid of this. Alright, so we have our next answer is 1, and we're going to add 72 degrees, which would be 108. I hope I'm doing this quickly in my head, and I hope I'm not making any mistakes here. Alright, and then we add 72 degrees again. And then we add 72 degrees again. And there's our final answer. So we found the fifth root of this complex number. Thus, because we have done that, we have 5 answers, and there's our 5 answers. Okay, so some pretty good math today. One more problem, we're finally finished with this homework assignment, number 69. Okay, we're going to find the sixth roots of -1. Now, let me quickly glance at my book here. Okay, if you'll look at number 65, the problem we just did, look in the book, we're finding the fifth root of -1. So for 69, we're finding the fifth root of -1 again. So students, there's really no need for me to do all the work in writing this in trig notation. We already wrote in problem 65, we already had -1 plus 0i, and we already wrote that in trig form. And remember what we got was 1 cosine of 180 plus I sine of 180 degrees. Okay, so there. So we've taken this standard form and we've written it in trig form. Alright, so good enough. And now we're going to use this, and the directions say for number 69, find the 6 roots. Okay, so really, we're going to take the sixth root of 1, which is just 1, and then we're going to take 180, we're going to divide it by 6, that gives me 30. And then we need 6 answers, so we're going to take 360 and divide it by our index. Our index is 6, and we're going to get 60. So we're adding 60 over and over. So 1 cosine of 90 plus I sine of 90, and then 1 cosine of 250 or 150, excuse me, 150 plus I sine of 150. I knew something wasn't right there with that answer. And then we're going to add 60, that'll be 210, so cosine of 210 degrees plus I sine of 210 degrees, and then 1 cosine of 270 degrees plus I sine of 270, and then 1 cosine of 330 degrees plus I sine of 330 degrees. Okay, so there's our 6 answers. Kind of a pain, but I'm going to check the back of the book. I have a feeling they wrote these in standard form. They did. And you know what? You can leave your answers there. It's up to you. You can watch me do this. I'll leave that up to you. But on a test or a quiz, I have all the right in the world to tell you to write these in standard form. So make sure you know how to do that, men. It's real important. I would watch this very quickly if I were you. I think it's just a smart thing to do, but I'll let you make that choice. I'm going to put my table right here so I can go back and forth to it real quick. And here we go. The cosine of 30 and the sine of 30. Well, the cosine of 30 is square root of 3 over 2. The sine of 30 is 1/2. So I would have square root of 3 over 2, square root of 3 over 2 plus 1/2 I. Remember, there's nothing to multiply this by because there's a 1 on the outside over here, so I'm going to ignore that 1. And there's one answer. Now 90, using your calculator, because 90 is not on your table, the cosine of 90 gives you 0, and the sine of 90 gives you 1. So I would have 0 plus 1i, or just I. Now the cosine of 150, students, that means I rotate 150 and I'm left with 30 degrees right here. So I'm really finding the cosine of 30 degrees and the sine of 30 degrees, as long as you remember that you're in this quadrant here. Okay, so please don't forget that. So referring back up to my table, I know that the cosine of 30 is square root of 3 over 2, but it'd be a negative. We're in the second quadrant, so negative square root of 3 over 2. And then the sine of 30 is 1/2, and sine is positive in quadrant 2, so positive 1/2. Okay, now 210 degrees, well, that means I would rotate 180 plus 30 more. So now instead of finding 210, I'm finding 30 degrees, but I'm in the third quadrant, and sine and cosine are both negative there. Okay, so this is really not that hard. It's just negative square root of 3 over 2, negative 1/2 I. Okay, 270 is not on our table, so I'm going to quickly find the cosine of 270 and the sine of 270. And that would give me 0 and negative 1, so 0 minus I. And of course, you don't have to put these zeros if you don't want to, okay? And then lastly, 330, that means I rotate 330, so I'm left over with 30 degrees. So instead of finding the cosine of 330, I'm going to find the cosine of 30 and the sine of 30, as long as I remember I'm in quadrant 4, and quadrant 4 means sine is negative and cosine is positive. So sine is negative and cosine is positive. So positive square root of 3 over 2, negative 1/2 I. So there we go. So here's all of your answers in trig form. Here's all of your answers in standard form. Really not that difficult. I hope this video has been a help to you. Call or email if you have any questions.